Hello. Okay, let's finish up our conditional probability notes. Let's turn to the last page of the notes. Okay. 60% of the applicants at a high-tech firm have a college degree. 40% have at least 3 years of experience, and 35% have both a college degree and 3 years of experience. So if an applicant is randomly chosen, we're going to find the probability that the applicant has a college degree or has at least 3 years of college experience. So the probability that they have a degree is 0.6. The probability that they have experience is 40%, and the probability that they have a degree and experience is 0.35. So, the probability that they have a degree or experience is equal to the probability that they have a degree plus the probability that they have experience minus the probability that they have a degree and experience. So 0.6 plus 0.4 minus 0.35 makes the probability that they have a degree or experience 0.65. Again, anytime you get a question about or, you're going to refer to your addition rule. All right. The production process produces a widget. On average, 20% of all widgets produced are defective. Each item is inspected before being shipped. The inspector misclassifies 10% of the time. So, what proportion of the widgets will be classified as good? So, we have the widget is either defective or it's good. So 20% of the time it's defective. That means 80% of the time, or 0.8, it's good. So if it's defective, it's either classified as defective or classified as good. 10% is misclassified. So if it's defective, 90% are classified as such, and there's a 10% that is misclassified. So you have 0.1 and 0.9. If it's good, it's either classified as defective or classified as good. So now, 10% or 0.1 is classified as defective, and 90% or 0.9 is classified as good. So we want the proportion that will be classified as good. So we're going to be looking at the probability that it's defective and classified as good, and the probability that it's good and classified as good. That spacing line, so we're going to move it back. Again, probability that it's good and classified as such. So, defective and classified as good is going to be 0.2 times 0.1, which is going to be 0.02. Good and classified as defective is 0.8. I'm sorry, classified as good times 0.9, which is going to be 0.72. So the probability that it's classified as good is 0.74. Adding those branches up. Our last example, still using the same tree. So we want to know the probability that it's good given it was classified as good. So remember, that's the and. So good and classified as good divided by the probability that it's classified as good. So that will be 0.72 divided by 0.74, which will be 0.97. So because it specifically asked for the percent, remember you're only going to give the percent when it asks for it. So that would be 97% of the time. This is what percent of the items shipped are defective. So now we want the probability that it's defective given it's classified as good. So the probability of being defective and classified as good divided by the probability it's classified as good. So that's 0.02 over 0.74, which gives us 0.03, which is 3%. You can also look at it if the classified as good was 97%, then the items shipped that are defective, subtract that from 100, which will still give you your 3%. So you have 2 videos for 1 lesson. Again, watch it multiple times, come in with questions.